Okay, so this is still technically topic 3. I just didn't want the video to get too long. So we're going to do this last example, example 4, all by itself. So example 4, we have mixed operations. So we have a mix of multiplication and division here. So we've already practiced multiplication, we've already practiced division. Let's kind of throw them together in one problem. So the first thing I want to address is this right here. I want to go ahead and take care of my division. I know that when I'm multiplying, I just multiply across. When I'm dividing, I keep my first rational expression or fraction the same, and then I multiply by the reciprocal of the second. So what I'm going to do is I'm just going to rewrite the stuff in parentheses, and then I'm going to multiply by the reciprocal of this last expression. So first numerator stays the same, second denominator stays the same, or first denominator stays the same. I multiply by the second numerator, which stays the same. Second denominator stays the same. And then this is where I have to be careful. Instead of dividing by this third expression, I want to multiply by its reciprocal, which is x squared plus 5x plus 6 all over x squared minus 4. Okay. And now at this point, everything is multiplication. We want to factor everything. So we've got 1, 2, 3. We've got 4 different things that we have to factor. So I'm going to start rewriting and factoring. So my first numerator is fine. X plus 2 or x minus 2 is as good as it's going to get. Now, my first denominator is x squared minus 9x plus 18. So I have a quadratic trinomial where a is 1, which is like the shortcut factoring. So I can jump straight to 2 binomials, start each with an x. And then what I'm looking for is factors of positive 18 that have a sum of negative 9. Well, in order to multiply two numbers and get positive 18, both of the factors have to be positive or both of the factors have to be negative. In order to get a negative sum, those two factors would have to be negative. So we could look at negative 18 and negative 1, negative 9 and negative 2, negative 6 and negative 3. And the pair that's going to work out for me is negative 6 and negative 3. If I multiply those numbers, I get 18. If I add those numbers, I get negative 9. So this is going to be minus 6 minus 3. Now, my second expression, I need to factor the numerator. The denominator is as good as it's going to get. So luckily for the second numerator, again, I have a quadratic trinomial where a is 1, so I can jump straight to the 2 binomials. And this time, I'm looking for factors of negative 12 that have a sum of negative 4. So when you're multiplying and getting a negative product, your factors have to have different signs. So one has to be positive, one has to be negative. And in this case, I need a negative sum. So I want my larger of the two factors to be the negative one and the smaller of the two factors to be the positive one. So I could do negative 12 and 1, negative 6 and 2, or negative 4 and 3. And the pair that's going to work out for me is negative 6 and 2. Okay. So I'm going to go x minus 6, x plus 2. Now, for my final expression, I have to factor the top and the bottom. So I have to factor both parts. So the numerator here is a quadratic trinomial. I can jump straight to the 2 binomials, again, because luckily the coefficient on the square term is 1. So for this one, I'm looking for factors of 6 that have a sum of 5. So in order to find factors of 6, both factors have to be positive or negative. And in this case, I need a positive sum, so we want both factors to be positive. So I could try 6 and 1 or 3 and 2. And the pair that's going to work here is 3 and 2. So I'm going to get x plus 3, x plus 2. Now the final factoring that we have to do is going to be that third denominator, which is x squared minus, x squared minus 4. So when you have the difference of squares, which is exactly what we have here, both of your terms are perfect squares, you're subtracting, you know you've got the difference of squares. We have to remember that it factors as the square roots of the two terms being added and the square roots being subtracted. So in this case, I have my first term is x squared. Its square root is just x. And then the second term is 4, whose square root is 2. So that final denominator is going to factor as x plus 2 times x minus 2. Okay, so let's see what we can cancel out. So right off the bat, I have an x minus 2 in my numerator, my first numerator. I have an x minus 2 in my third denominator. Those cancel. X minus 2 divided by itself is just 1. Next up, I have an x minus 6. My second numerator and my first denominator both have an x minus 6. X minus 6 divided by itself is just 1. I have an x plus 2. So my second numerator and my second denominator have an x plus 2. X plus 2 divided by itself is 1. Let's see what else. I think I've got one more. So my third numerator and denominator both have an x plus 2. So x plus 2 divided by itself is just 1. So let's see what we're left with. Let me find another color. We'll do yellow, even though that one's kind of hard to see. So looking at all of this, I'm left with an x plus 3 and an x minus 3. So that ends up being my final answer. Everything else is just a 1. So my final answer is x plus 3 over x minus 3. And that's it. Okay, so nothing crazy here. This technically is part of the previous topic, but the video is getting a little long, so I separated it. So when you have mixed operations with multiplication and division, just rewrite the whole thing as multiplication and then factor everything and simplify.